You got it?
Yeah.
Oh, just in case. I was gonna get it. Is the guy named Michael or no? Is that you?
Yeah, that's me.
Okay, that's good. There was supposed to be two other people. Wait, what do you mean? Isn't the link there already without having to make the announcement?
Yeah, it's gonna mess up. Yeah.
Fine. There's no way of saying.
I'm gonna talk to you from computer professor. Thank you.
Oh, yeah, okay, what's that? Okay, one second. No, but it's there. I have a preset schedule of for every Monday night. I clicked on it. What? Yeah, there's two more. What happened to the other guy? That other guy, he's supposed to send me.
They just don't want to use two. Came earlier, I don't know. And there's two people here. What's your name again? I'm sorry, Aries. Aries, and he's looking. They're going to use one computer.
Okay, so now I got another person, Gianna, for just signed up. Okay, so when he
Hi,
shows up,
Professor.
hi there. This is I'm glad we could get together. Is there a couple of other? With that was just wait a few more minutes just in case somebody else shows up, or I'll tell them to just tell them to. That's what's going on. Thanks a lot. Bye. Hi, everybody. Okay, so we have Yana, Michael, and Michael's with who's with Aries. Nope, everybody got muted. Michael, can you hear me? Okay, so
That's how I feel sometimes.
let me just get a pocket actually.
Yeah.
Okay, so John is there. See if we can find that.
Is he talking? No, I don't think he's talking. I could hear us. I'm unmuted. Professor?
One second,
Hold on.
hold on. Give me 1 second, please.
Okay, my bad, my bad.
Okay, so we expect one more person to join, but meanwhile we can begin. I think I'm going to try to answer Michael's question first because the chapter 7. What I'm going to do is I'm going to try to start. Person to the place. Look on chapter 7. In chapter 7, there are 4 examples. So, Michael, which example do you want me to do?
Professor, I can't really understand you too well.
Oh, I'm sorry. Okay, that's the other problem. Whoops. I have this issue where I have to put up. It's better now, right?
Yeah, 100%. Thank you.
I'm going to put the microphone in front of me. I got to have these earphones, which I got to learn how to use. Okay, now the computer's open in front of me, and the microphone is right in front of me. So there are 5 questions. But which one would you like to? Is the one with the problem?
Just question number 5.
Okay, I'm clicking on question 5.
I'm amending it right now.
You don't see it yet because I didn't say share screen yet. Okay, I see the 5. Oh, this is a good one. I mean, that's the classic example in chapter 7. We actually demonstrated the first day of class, I think, even, and I have some videos on that. But let me just go through it. It's very
Where your
straightforward.
videos posted? Is it just under that one Word doc?
It's all, I mean, let me just do it for you. It's under a Word. I have, let me just do it. Then I'm trying to worry about where to find
Okay.
it. But I got to share my screen. So I've got to go down to here. Got to go to share content. And it's going to tell me probably right here.
And my Pearson. So as he's doing
Okay.
it, we could replicate it.
Okay. So do you see the screen?
Yes, sir.
Okay. So the first step you go through, so again, a lot of examples, not this one, they give you a bunch of data. And then you would say, open in StatCrunch, you would go click on the data that's someplace around here, a little blue icon, and you would do it that way. In this case, there's no real data. It's just so you have to remember the example itself, which says that we need to find the area or the probability of being beyond, like, over 6.8, between 0 and 7.6, etc. That's a great example to solve using StatCrunch calculator. So help me get more help. I'm going to say open up in StatCrunch. Okay, and then I'm going to go into Stat Calculator. This time, again, in other chapters, you're going to be using maybe the T, but I'm not even sure of that. But in this chapter, you're using what's called a normal, because we're told it's a normal bell-shaped curve. And this is what opens up. And this solves the problem for you, because there are three kinds of problems. There's problems where you want to know the area below a certain point, in which case you use less than. Other examples, you want to know the area or the probability to the right of a certain point, higher than a certain, so you change this to a greater than. And then there's a totally different kind of question. Well, not really totally different, but where you want the area between 2 points, which I don't think is a question right now. You click on between. But right now we're doing the standard problem, greater than. Okay, so we need to be told four things.
I'm
to
sorry,
solve the
Professor. Your
problem.
wife's leaving.
Okay, say goodbye to me.
Have a good night. Thank you
Goodbye.
so much. Thank you.
Okay, thank you. Okay, so we want the area, so we need to know three facts, which they have to tell you. They have to tell you that the fact that it's a bell-shaped curve by saying it's normal or bell-shaped curve. Sometimes the word for it is Gaussian, but they don't use that word so much. And we need to be told the average value. What is the middle value of all these numbers? And I think they tell you it's 5.9% is the average,
Mm-hmm.
because I can't even see it. Then you got to be told the standard deviation, which is
They
what?
give you that.
Okay, 1 point something.
Mm-hmm.
What's the actual standard deviation? Do you remember the example?
No, I can't see
It
it.
was 1.7, and the
No,
mean
not
was
not not yours. His. Because
Oh,
he's
his?
doing an example on his. Yeah, I can't. I don't
Oh, the
remember your numbers.
example.
I have to find. Let me find the problem for it. Where it go? Here's the problem.
Doing his example.
5.9 and 1.8 is the 1.8.
1.8.
1.8. And we went over 6.8. 1.8. Where are we? Whoop, okay. 1.8 goes here,
Want to be greater than.
and we want it to be higher than 6.8.
Mm-hmm.
Now, let me point out to you one slight complication in this problem, which is that everything's in percentages. But the percentages in this case are just like units. So it could be like
Yeah.
5.9 pounds with a standard deviation of 1.8. The percentages, which may, screw you up, is really just can be ignored. If you convert everything to percentage, like instead of 5.9, you put down 0.0059, which is 5.9%. You
Mm-hmm.
convert everything to percentages into decimals, you get the exact same answer. Or if
Mm-hmm.
you just, in this case, just drop off the percentage sign and ignore it because it's sort of the same in everything. So that is just one slight calculation. So we plugged in the number they gave us. We plugged in this number. We plugged in this number. We changed this to a greater than, because remember we want everything to the right of 6.8 greater than, and then we hit compute, and the answer is 0.038 or 31%, 0.0308. So if we take this number and plug it into the answer, copy, go back to the problem
Multiply by
somehow.
100 first.
1 second, let me go back to the problem, and we type. Okay. So again, the answer itself has to be expressed as a percentage. So again, go back to the answer. So it's going to be 30.8% or 30.85%, again, by moving it over two places. So the answer is 30.85. We'll go back to the problem. 30.85 and hit check answer somewhere. Oh, there it is, check answer. And we got it right. Okay. You want to do another? You want to do another one?
Yeah, we might as well just do one for the in between. We could do that quick.
Okay,
if
so
you don't mind.
0 to 7. So all you got to do is change, go back to this thing here,
Mhm.
change it to between. And now we're going to be somewhere between 0 and 7.6. And compute. And the answer is 82.7%. Let's see if that's right. 82.7. And check answer. And it's right.
Okay. I really
Now,
appreciate your time,
you
Professor.
expect
Thank you
it-
so much.
And this is more than 1%. You know, it just matters continuing. Again, we want more than. You got to be sensitive to more than, like over or more than versus less than. That's the only trick you got to be aware of.
Okay. One more question. When is the group project due by?
Well, again, I'm pretty, if you notice, I'm pretty lackadaisical about deadlines. It's really due the last day of the term. But there are two things that might change that. One is, which I haven't really decided yet, even though it's coming down, it's getting a little bit late in the term. I haven't decided if I'm going to ask people to present the project to the rest of the class. This way, you know, when you watch people get feedback, other people's projects, you'll know how to improve your project. So I may decide that. That's the good side of that. The downside, it becomes a hassle to, you know, for everybody to present it and to be paying to be there. So I'm not sure. Maybe I'll just get personal feedback. So that's the other reason for doing it earlier. If you give it to me earlier, I can tell you, you know, like everything else, you get a second and third shot of it. If you give it to me early, I can say this is right, that's wrong, that's wrong. So by changing it, you get a better grade. If you give it to me the last day of term, I can't really improve your grade. You'll be stuck with whatever you get.
Mhm.
So
Okay.
it's better to give yourself a deadline of, I don't know, at least a couple of weeks before the end of the term. The more time you give yourself, the better. You know, I'll turn it around quickly, and then you can improve it. But if you give it to me the last day of the term or 2 days before the end of the term, I can't promise I'll grade it and give you a chance to redo it. So it's
Okay.
really up to you. So if you're confident you're getting it right, and it really shouldn't be, you know, basically you're gonna, if I approve the date, I don't know if I did your project. Now, if I approve approve the project and approve the data, then it's just a matter of grinding out all the formulas based on, I give you a table of contents with all the formulas that I want to see there. So you'll make, you make some graphs, you make some mean, medians, and modes, some t-tests. I mean, you may not be up to date yet. That's just past chapter 7, but you'll, you grind them all out, and so the stat crunch will make sure the numbers are right. Then it's really a matter of just interpreting them, and that's pretty straightforward most of the time. So if you're confident, you can do it, hand it in just once at the end, but probably better to give it to me a couple of weeks before the end of the term.
Appreciate that. Thank you for your time.
Okay, so again, it's up to you if you want to leave now or if you want to stick around to listen to other people's questions.
Are they at chapters ahead of us or?
Well, I imagine most people have questions about because remember, you needed to finish chapter 7 to do the first test. Am I right about that? Chapter 4? No, I'm sorry. This is stat 1. I
No,
apologize.
it's the second test.
This is stat 1. 1 second. The first test is chapters like 1, 2, and 3, right? 3 or 4.
Yeah.
Okay. So they're probably. I don't know. We'll find out in a second. I'm gonna close this out. I'm gonna get out of stat crunch. Get out of this homework. And leave. But we're still in the homeworks themselves. Oh,
Professor, I think I'm going to leave. I really appreciate you for your time. Thank you so much. Have a good evening.
No problem, Michael. Okay, so now, Gianna, first of all, am I pronouncing your name correctly, Gianna? How do you pronounce it?
Yeah, you got it, Gianna.
Gianna, okay.
Yeah.
Now, you asked about, you had some questions. So first, maybe just tell me the questions, and this way maybe we coordinate with Parker to make sure we answer everybody's questions. Just tell me what would you like to learn about?
So I just had questions about like the project and StatCrunch, and then I also had specific for chapter 11, the T distribution on how to solve that on StatCrunch.
Okay, fine. So I'll be glad to answer both of those. And Parker, what were your questions?
I just had a question on chapter 11.
I'm sorry, I can't hear you. Like very low. Parker? Parker, are you there?
Yeah, can you hear me?
Oh, now it's much better. Okay. What was
I just had a question on chapter 11, problem number 5 in the homework.
Okay, so both of you guys went to chapter 11. And so let me do that first, and then if you want to stick around for me to talk about the project with Gianna, you can. So let me answer chapter. So let's go to chapter 11. So I'm going to go to assignments, assuming you can still see my screen, homework. Oh, why am I? Oh, chapter 11. Oh my God, it's pretty advanced already. Okay, and which question? Let's take Gianna first. Which is your question? Ladies first.
Question 4.
4. Okay, and Parker, what was your question?
Number 5.
All right, let's start with 4 then. Okay, 4. So it's opening up. Okay,
You could just open it up in StatCrunch and then go to stats and then go down to T.
right. Well, the reason why I was hesitating is because there are 2 versions of the confidence of a lot of these formulas in chapters 11, 12, and 13. One is the Z version, and that is when the standard deviation. I don't know if you can you see when I move move the cursor? Are you seeing that cursor also?
Yeah.
Okay.
Yeah.
If the standard deviation it's subtle. If you're a statistician or you've done this for a while, it becomes obvious. But the first time you do it, like in Stat 1, it's easy to make the mistake or be fooled by it. The good news is if you get it wrong, you just can do it again. So yeah, can't really. It's not like that's the great thing about this class. You can take the test and the homeworks again. But if the standard deviation is given to you, like on a silver platter, like they say, the standard deviation of the population is such and such a number, then you go to the Z. What's much more common, both in real life and I think in the homework, is the standard deviation is estimated based on the sample. So when they say the sample was taken, that's where the average came from, and that's also where the standard deviation came from, and that means we're going to go to the T. So that's the first. That's just knowing where to go later on. So you open up the data in StatCrunch, so it's all there. Hopefully, when it opens correctly, and then you go to Stat. And you go to T-stats as opposed to the Z-stats. And we have one sample, and we have it with the raw data. In other words, sometimes they give you the actual average. Well, they did in this case. Actually, we can do it both ways. You can either they give you the average and they give you the standard deviation, but we can actually use the raw data. So we don't have to go here. We can take the raw data, and it's one sample. So let's go here. And we only have one column, one bar, so we don't have to rename it. We don't need where, we don't need group by. We want to do confidence interval, so we change that. We change this to 80%, so it's 0.8 or 0.8 even. And I think we're ready to compute. And the answer is it's a low of the average, 33.04, which hopefully matches up with what the book told you. And it's 30.7, 35.3. So let me let's make sure that it matches up with the books, with the question itself. Yeah, 33. So it's telling us the same thing, 36.6, 8.69. Let's see that. Okay, so here's something again just worthwhile pointing out. They told you the standard deviation was 8 point something, 8.9. What did they just say? 8.9 or something. but that doesn't seem to show up here. The average matches up. Instead, they give you something called the standard error, which is equal to the original standard deviation divided by the square root of the sample size. The sample size was 25. Square root of 25 is 5. So if you take that 8 point whatever and divide it by 5, you should be getting this number here. The standard error is another way of measuring how much variation you expect from average to average. If you took another sample of 25 and another sample of 25 and another sample of 25, which is necessary for the theory behind this thing. Anyway, the bottom line is the answer is 30.7 to 35.3. So we can do 30 points. So where do we put the answer? 30.7. So 30.7 and 35.3, I think the other one was. And we can check answer and hopefully we did it right. Okay. So Jan, does that answer your question?
Yes.
Okay. Do you have any, what about the other parts of the problem? The margin of error, I believe, this is, I'm always forgetting this is something very, basic, and it's easy to, again, here's what, the margin of error is either equal to the standard error that we just saw before, the 1.78, or it's twice that number. You understand? Now, you can either look it up in the book, we could ask you can go through, you know how this works. You can either tell the computer to do help me solve it, and they'll walk you through it, and then they'll come to the point where it says find the margin of error. They'll tell you the formula is you take that standard error and you double it, or you leave it alone. We can try it by trial and error, or you view an example. Do you see what I'm saying? I'm not giving you the exact answer, but that's how you would get it. Okay, so we can try it. What did we say before a second ago? The margin. Do you remember, Peter, what it was? Is it twice the margin of error or just the margin?
What I did was I subtracted the mean from the lower. So I subtracted, I think, 33.04, that mean, subtracted by 30.7. I think that's what I did.
Oh, so that's the width of the confidence interval. That's interesting. That means it's not either of those two. It's not the standard error. It's a standard error multiplied by the t value, which is which is another way of doing it. Okay, we could try that. What were the differences? Anybody have a calculator? Oh, I'll give that. 35.3 minus 5.7. That comes out to 5.6. I think it comes out to. Let's see if that's right. The calculation was right. Check answer. Incorrect. Here it is. Okay.
No.
So it's equal to t times the standard error. So I think it's that number divided by 2, because this seems to be you take the standard error, which they give you. So it's probably half of that. So it's 2.3, I guess. Let's try 2.3.
What I did was I subtracted the mean, so 33.04.
Oh, I see. You're already. I see. You're already halfway there. So it comes out the same thing. You subtract the high minus the low divided by 2.
Yeah.
I think that's right, but I wouldn't bet my life on it. But yes, that's it.
Yeah.
Take the high and low divided by 2. Now comes the third question. This is the answer that I started talking about before, because I seem to remember this question from before. If the standard deviation of the population is known, it's not based on a sample of 25, it's just known based on, I don't know, previous work or theory, then instead of going to the z, you go through the same example again, but you go through the t this time. So stat, and this time you're going to go to z calculation, one sample with data. No, it's not going to be with data. It's going to be with summary, because we have to if you use the data, then we'd have to plug in that will come out to the standard deviation of the samples. Let's use a summary. So we know the sample mean was, anybody still recall what it was? 33.04. The standard deviation now is 9. The sample size is 25. Went to get an 80% confidence interval. And we can compute. And this time it's 30.7. Looks like the same as before. 1 second. 30.7 by 35.3. It would be exactly the same. 1 second. What does they say? Oh, that's annoying. It comes out exactly the same. So they want to know is the new interval smaller than the old one. I guess we have to do it to 2 places to see the difference. Okay, so you understand I rounded it to 30.7, but I forgot the original number. Gianna, you with me?
Yeah, I am.
So we just the main thing is you got to go to the 33.04 and 9. So let's write it down to two decimal places. Okay, let's go down to 2 places. Go back to the answer we just saw. 33.73 and 35.35. 30.73 and 35.35. And I don't know if it's this isn't okay. I don't know what the original one was. Oh, let's assume that it's wider because I think the other number was I don't remember, but I think it was. Let's just try 30.73 and 35 and check answer. Hey, we did it. Okay. Is that clarified for you?
Yes, thank you.
Now, the reason why, again, I'm just going to complain about the problem. What would have been an interesting problem is that because when you go to the Z table, the numbers are smaller than the corresponding percentages on the T table. If this was the exact same standard deviation, 8.69 and 8.69, it would still be narrow. So that would be a useful, from a pedagogical point of view, would be a very useful question. What we're doing is using the exact same numbers, but changing the assumption to the population standard deviation. And then the answer has to be that it's going to be more narrow. But here they changed 2 things simultaneously, which takes away the benefit of this problem, really. They changed it, made a population, so we had to go to the Z, and they also changed this number from 8.69 to 9. So even though the answer is right, it's really a useless from an educational point of view. Okay, that's my complaint about the book. Maybe I should tell them. Okay, Gianna, anything else?
No, just question 5 would be good. I think he wanted that.
Okay, so let's move on to Part 5. Let me X this out. Say leave, get out of this, get out of that. And now we go to question 5. See if that's okay. I ran up to okay, so this is it's very straightforward. Again, you're going to go use the fact that we're given the S. Okay, that's the sample standard deviation, as opposed to the sigma, which would be the population standard deviation. So we know we're going to go to the T table, and we're going to plug in. We know the sample size is 20. I mean, the truth is you can actually do this by the formula, but that's again a nice thing about this whole class is very few formulas you really need to know. Just going to plug it in. So we're going to go get more help. Go to StatCrunch. Try to remember the 439, 29, and 20. So we're going to T-stats, 1 sample, as opposed to the next chapter when there were 2 samples. And here we have just a summary. And we're going to plug in which I forgot already. Do you remember what it was? Anybody remember the sample average? You can check.
I'm not sure.
439, 29, 20. 439, 439.29.
And then 20.
Size is 20. And believe it or not, there's not too much else to do. We want to do a confidence interval. I think they asked for, do you remember it was 95%? Here's the 95% confidence. So let me just again check the question. This is the most tedious part of it. 95%. So what did they just say the answer was? 4.25 and 4.53 when you round it. 425, 453. 425, 4.25, 4.53. Check answer. And we got it. Like 90%. Well, that's easy. You just simply change that to stat, z-stat, one sample with summary. You just change it to an 80. Oh, what do they say? 90. That's all. And you just hit compute. Does that solve it for you, Parker?
Yes, thank you.
Anything else?
That's it. Thank you.
All right, great. So if you want to hang around while I answer Janice's other question about the project, you're welcome to do so. But if you got to go someplace, I'll see you again. Um, again, we're not limited to the 7:10. You can, like on this one, you can give me an email anytime during the week. I'm always near the computer. I can always set up a WebEx and answer any particular question, on the spot.
Okay, thank you.
Okay, my pleasure.
Thanks again.
So, Gianna, what was your question about the project?
So working on StatCrunch, how do you save it so you could open it up again without doing it all in one shot? Because I didn't know how to do that.
Okay,
Because
so
I
you're-
opened up my data and I was kind of working with it, and then I went to save it, but it saved as like an internet link to my desktop, which now I can't open.
Okay, one second. You're talking about, okay, I'm not 100% sure what you're asking. You're asking one of two things. You're asking me, how do you save the data from your project, or how do you save StatCrunch type data?
I guess it would be stat type crunch data because we're doing the project in StatCrunch, correct?
Right, okay. So it's supposed to, but where did you get your data from? Did you get it from Stat originally?
Yes.
Okay, one way to do this, one way to do it, you want to know something? I don't remember actually ever saving my data in StatCrunch. I bet there's a way to do it, and we can do it together. But another way to solve this problem, practically speaking, is just to save it in Excel. And every time you want to do some more analyses, you import the data, or you just cut and paste the data into StatCrunch from
Oh,
Excel.
okay.
Then that would work as well. But let me just show you. Let's try to do this together. One second. Let me see if I can.
Because then I guess if you have the Excel, then that would be more collaborative with the other people in the group.
Yes, you can do WebExes among yourselves. You could do Excels.
Yeah.
Different ways of doing Google Docs. There's a million ways you can do this as a group. But let me just think. It's a good question. I never came across it before. Let me just see. Question 2. Have data. I'm looking for a question with data. There it is.
Yeah.
This is data. Okay, let's open the StatCrunch. We have the data. Okay. Now, so how do you save it? Well, I very rarely go to, certainly Stat 1, have to go to data, but we had there, there's another, we're not using all this stuff. We're just using mostly stat,
Yeah.
and a little bit of graph. But let's go to data, which is a logical place, and you say save. They're probably going to ask you to save it. Call it my stat lab data set. Overriding store session information after saving. I'm not really sure what's going to happen next. If we say save, where's it going to go? I don't know. We'll find out. My stat lab data set. I'd rather call it by name so maybe I'll notice the name. Let's call it X test 1. It was the first time we're doing it. I'll hit save. Saving data. My data folder. Who knows what that is? It's hard to believe that when you log in, it goes by your name. So it's like I logged in under my name. So maybe there's something under your name. Let me just try it. So let me get added. So let me first of all, if I can find it again, load data from file
Oh, okay.
on my computer. I'm gonna hit on my computer. I don't know where it's going to go, but drag a file here. So that didn't work, right? Let's just see. I don't care about the homework now. I wanted to stay in StatCrunch. Let's see, where was StatCrunch? Okay, so your data was saved.
Or maybe if you go to data and then load and then click my data.
Oh, my data. Okay, thank you. I didn't notice that. That's a good idea.
And maybe it should be.
There it is. There it is.
Oh, wow.
And it's, and it's under X test 1.
Uh-huh.
Just clicking on it. Loading it. There it is. So you can't save your
Okay.
data. And the question is, how do you, you know, theoretically, you could work on, let's say, chapters, I don't know, 3, 4, 5, 6, and someone else can work on chapters 10, 11, 12. You could theoretically just send them your data. Let me see, but it got to be somewhere on your computer. So it says, let's just find it again. Stat. Oops, sorry, data. Oh, well, there's also something called share. Maybe you can send somebody the data. Let's try that. I never really did this stuff. Creates a link that someone else can, I don't know how they open and share with everyone in groups. I guess, the answer is
Okay.
update share stat. I guess theoretically, you could probably learn this by play. It's like you just figured it out, play around
Yeah.
with it, and ship somebody a data set or a link to a data set. That might be a very good way to do it. But it might be the easiest just to have like one, either a Google Docs file, um, of Excel that you can send back and forth, or something
Yeah.
like that. I mean, there's many ways you can do it.
And then I guess also for the proposal, you want us to have like our means and standard deviations calculated?
No,
For it?
the proposal is simply to say the following. I'm planning to study, I don't know if this is your project, but somebody came up, they probably got it out of StatCrunch, which has like 4,000 data sets. It's possible it was someplace else. They said, we're going to study, uh, compare Kellogg's to, there's a data set with different cereals. So there's
Mhm.
Kellogg cereals, Post cereals, what shelf they're on, lower shelf or an upper shelf, and how many calories it has, how many grams of sugar. So that, so you would just tell me the data set itself, either by sending me a link or better yet, just showing me the actual data like in an Excel file. So it's just,
Okay.
I just have to verify that there are at least one categorical set of data like male versus female or Kellogg's versus Post, and that there's a
Mhm.
couple of numerical data set, variables in your data set. And that's it. Once I verify, then you can tell me you're planning to analyze it. And you don't have to tell me what you're analyzing, because what you can analyze is the formulas that I tell you in the table of contents. And you might want to give me a little blurb just to say, well, we're going to answer the following questions. Does Kellogg's have more sugar than Post or something like that? But I'm not really marking that. I just want to see that that your data is reasonable and you know how to
Yeah.
handle it. And that's it. So the proposal can just be mostly the data and
And is that
so
just through an email? Like just to send you an email?
the best way is through an email. This way I have it. I can send it on to my GA.
Okay.
All right.
Perfect. Thank you so much.
That's it. Everything else good?
Yes, that's it. So far, everything's going well.
Yeah. Then if it shouldn't get any more difficult than this. Okay, great. Thanks. I'm glad we got a chance to get together and we both didn't have to come to class. I wasn't able to make it tonight, so this is good.
Oh, that's okay. Thank you so much for meeting.
Okay, anytime.
Have a
Bye-bye.
good night.
Good night to you.